Welcome. Hello, everyone. My name is Mathias Vuille. I'm a professor and climate scientist at the University at Albany. And today I would like to talk to you a little bit about how climate change affects Andean glaciation in the tropical Andes. As you can see here from this first slide, this is work that involves a large group of people. I would like to acknowledge all of my collaborators. We have been working on this topic for many years, and I should also briefly acknowledge funding from the National Science Foundation, UNESCO, and the US State Department. So when we talk about Andean glaciers, glaciers are really unique in a sense that they give us a direct and fairly immediate picture of what is actually happening in our environment. So they're very visual indicators of climate change and how our environment is changing. And we can show that by going back to the same place over a period of many, many years and document how the extent of glaciers is actually varying. I want to show you just a few examples. This is what we call repeat photography. And we're starting here in the Andes of Venezuela, Pico Bolivar. The glacier is called Glaciar Espejo. And you can see how this glacier has retreated and over the course of the 20th century completely disappeared. There's a little bit of ice left on the backside that we can't see, but we project that Venezuela essentially will become ice-free very shortly. Here's another example. These are images that were provided to me by my colleague Jorge Luis Ceballos from IDEAM in Bogota, the Sierra Nevada del Cocuy in Colombia. It's a very similar environment as we just saw in Venezuela. You can again see a fairly rapid retreat and thinning of the glaciers. We have several mountain glaciers left in Colombia with ice currently, but they're in a similar predicament. The mountains just aren't high enough, and we estimate that much of this ice will be lost in the coming decades. We can go a little bit further south in the tropical Andes. We are now in the Cordillera Vilcanota in Peru, and we're looking at what used to be the world's largest tropical ice cap called Quelcaya. And in the two pictures in the bottom, they are taken 15 years apart. You can see how this ice cap has rapidly retreated. You can also see how it has been thinning over the course of these just 15 years between 2003 and 2018. And finally, one last example that I quickly wanted to show you. This is now in Bolivia. This is a glacier called Chacaltaya. It's a very famous example because it used to be the world's highest ski resort. When I first visited this place in the 1990s, people were still skiing here. It's only about an hour's drive from the city of La Paz. And by 2009, as you can see, this glacier had completely disappeared. What happened here is that the freezing line, the altitude in the atmosphere where temperature is 0 degrees Celsius averaged over the year, had been going higher and higher and basically elevated above the peak of this mountain, meaning that this glacier had lost its accumulation zone, and no glacier can exist if it doesn't have this zone of accumulation where the mass balance is positive averaged over the year. Now, these images that I showed you, they're kind of anecdotal, and we of course need to look not just at some photographs, but we need to look at hard data to see what is actually happening in the Andes. And a few years ago, we published a study looking at all the data we have from the tropical Andes. It was led by my colleague Antoine Rabatel from the University of Grenoble. And you can see here in these different colors and black symbols how glaciers in Peru, in Ecuador, and Bolivia have retreated throughout the 20th century. And you can see that in the early part, the 1950s and the 1960s, we just have snapshots in time. These are mostly based on aerial photographs, satellite images. But since the 1980s and the 1990s, we have fairly good records, and you can see that all these glaciers have been retreating rapidly. All the trends are highly negative. Now, the length changes of glaciers are not necessarily the best metric, the best indicator to look at what is happening with glaciers. A better way of looking at this is to look at the actual mass balance, because that tells you the actual amount of water stored in the ice that we are losing. This looks like a very complicated figure. Each one of these little colored squares is a different study, but the most important line is this black thick line that you're seeing here. And you can see that it's also trending down, and most importantly, in every year, these values are negative. And we are currently losing about 0.6 or minus 0.7 meters of water equivalent every year, clearly documenting that the mass balance on these glaciers is highly negative. Now, why is this happening? In theory, it could be that it's just not snowing enough anymore, that in the tropical Andes, the climate is getting drier and that the glaciers are basically starving. But there's no evidence that this is actually happening throughout the Andes. And the other possibility is that the climate is getting warmer, the temperatures are increasing, and therefore we are seeing increased melt rates on these glaciers. And that is, we believe, what is actually happening here. You see two different figures here, Chacaltaya in Bolivia on the left, and Antisana, a glacier in Ecuador, on the right. The two lines that are shown here, the blue line, that is temperature at 500 hectopascal, that is temperature at roughly the elevation of the equilibrium line altitude of these glaciers, so where the annual mass balance is 0. The brown line is the mass balance. And you can see that these two lines are highly anti-correlated. For example, here in 1998, this was during a strong El Nino year, temperature was very, very warm, so the mass balance was very, very negative. While in the following years, temperature dropped and the mass balance became more positive. So clearly, these two variables are anti-correlated with one another. And that is true in the outer tropics in Bolivia, but it's also true close to the equator in the inner tropics in Ecuador. Now we know the temperature has been going up in the Andes. This green line that you're seeing here, that is the increase in temperature that we have observed between 1950 and 2010. And you can see the temperature increased by roughly 0.13 degrees Celsius every decade. The red and the blue lines that you're seeing here now, these are projections. These are estimates of how temperature will continue to increase throughout the 21st century. Now, there are large uncertainties here, of course, because depending on the model that you're using, you may get a different results. And it depends, of course, also on the emission scenario that we're considering. And that's what's shown here in blue with what we call RCP 4.5. That is a moderate greenhouse gas emission scenario, and RCP 8.5, a high emission scenario. And depending on the scenario that you want to look at, depending on the model that we're looking at, you can see that we estimate the temperature by the end of the century will increase somewhere between 1 and almost 5 degrees Celsius compared to today. The other thing that is important to keep in mind is that temperature will not increase by the same amount everywhere in the Andes. We know that temperature increase is elevation dependent. What that means is that the higher up in the Andes you go, the stronger the warming will be. And that's shown in this figure here. The y-axis here shows you the elevation of the Andes above sea level, anywhere from just 500 meters up to 4,500 meters above sea level. And the x-axis here shows you the actual estimated warming by the middle of the century, between 2040 and 2070. Again, we're looking at two different emission scenarios, a low and a high emission scenario. And the green and the yellow dots, they are the projected warming that is slightly different, whether we're looking at the western slopes of the Andes in yellow or the eastern slopes in green. So what does that mean for glaciers in the Andes going forward? How can we use that information to estimate how glaciers will respond to future climate change? The different ways we can do that, we used in our work a fairly simple approach, and that is we looked at how the freezing level height, so the altitude in the atmosphere where temperature is 0 degrees Celsius, how this elevation will change going forward. We did that because in the tropical Andes, this freezing level height is closely correlated to the equilibrium line altitude. So the altitude on the glacier where the mass balance is 0. And we can show this here by looking at these different scatter plots. So what's shown here is exactly this relationship between the equilibrium line altitude, that's the y-axis, and the freezing level height above sea level in meters, that's the x-axis. We did this analysis for different glaciers. So in red, these are results for the Songo Glacier in Peru, in Bolivia. In green, that's Artesanrajo Glacier in the Andes of Ecuador, and in Peru. And in blue, this is Glacier Antisana in Ecuador. And in all three cases, you can see that there's a very close correlation between the freezing level height and the equilibrium line altitude. So we can use this relationship now to project how the equilibrium line altitude will change going forward. And I'm trying to explain this here again using this example of the Calcaya ice cap in Peru. This is work that was done by a former PhD student of mine, Christian Jarlecke, who now works at IDEAM in Huaraz in Peru. So shown over here on the right is the projected future change in this equilibrium line altitude in meters. Again, for two different scenarios, a high emission scenario in red and a low emission scenario in green. Also shown here by this dashed blue line, that is the highest elevation of the Calcaya ice cap. So that's up here. Once this projected equilibrium line altitude crosses this blue dashed line, goes above the highest elevation of the ice cap, that is when we are basically at a stage where we know we will lose this ice cap. The ice cap essentially becomes doomed. And this is, according to our projections, going to happen somewhere around the middle of the 21st century, around 2050, in this high emission scenario. So in this high emission scenario, we will eventually lose all the ice on Calcaya ice cap. In the low emission scenario, you can see that we'll likely will still stay just below the summit by the end of the 21st century. Here are a few other examples. This is an example for Antisana. So Antisana is here in the Andes of Ecuador. And again, here you can see by the end of the century in the high emission scenario, we enter a situation where we will lose this glacier, while in a low emission scenario in blue, we stay below this dashed line, the highest peak of this mountain. Here's another example, Artesanrajo. So this is in the Cordillera Blanca in Peru. And you can see here in both scenarios, we estimate that we will stay below the highest elevation of this mountain, meaning that we'll still have a glacier by the end of the century, but it will be significantly smaller than today. And the same is also true for Songo Glacier in the Andes of Bolivia in the Cordillera Real. Now, why does all this matter? Why do we actually care about tropical glaciers and whether they will disappear or not? I wrote down here a few examples, a few aspects why these glaciers are important. For one, of course, they're important for water use. Andean glaciers, they kind of behave like reservoirs, like dams. They retain water during the wet season. They release it throughout the year, and thereby they guarantee that we have a steady base flow in the rivers downstream during the dry season or during droughts. Glaciers can also lead to hazards, environmental hazards in mountain regions when they retreat, for example, and they release a lot of meltwater. If that meltwater is dammed by moraines down valley, it can lead to proglacial lakes And if these dams are breached, it can lead to so-called glacier lake outburst floods or GLOFs that can lead to mud flows downstream. That can be a hazard. Glaciers are important for ecological reasons downstream. Glacier meltwater has a specific temperature, turbidity, chemistry. Aquatic life downstream has adapted to these conditions for long periods of time. So glaciers are important to maintain those ecosystems. Glaciers are important for social political reasons. As I mentioned, the water use, when glaciers retreat and water becomes scarce, it can lead to conflicts in terms of access to water, allocation to water, who determines who gets water when and how much. Mountains in the Andes are important for tourism, for mountaineering, alpinism. As glaciers retreat, this can have significant impact. And also for cultural belief systems. For indigenous populations, the mountains are sacred. In some regions, they're considered to be the home of gods. And of course, the local population is observing that these environments are changing very, very quickly. So I just want to quickly mention a couple more things related to the water supply that I think are important, because sometimes there's some misconception here. While these glaciers are important for water supply, they're not equally relevant everywhere. They're most important close to the glaciers. And as we move away from the glaciers further down valley, the relevance of the glacier diminishes, because the supply of the water from the glacier becomes more and more diluted as we go away from the glaciers. It also is important to recognize that we have other buffers beside the glaciers, and particularly in the tropical Andes, such as Colombia or Ecuador, that have a more equal distribution of rainfall throughout the years. We have paramos there that have a very high water retention capacity that can also take on this environmental service provided by glaciers. Glaciers are most important in southern Peru and in Bolivia, where we have a very long dry season, where we have several months of the year where these glaciers really provide the only water source. And finally, there's a number of studies that have shown that we should not just look at the supply side, but also the demand side. So what that means is that these studies have documented that we will run into water scarcity issues even without climate change in some of these locations, because the population is growing, economies are growing, so the demand for water is going up, and it might lead to allocation problems even without climate change. So I will end here now, but I just wanted to mention that we have worked on this for many years, this issue, and we have written not just scientific papers, but also a series of publications in Spanish, publications for policymakers, decision makers, and the broader public. They are all publicly available. You can download them, for example, from my website. And finally, I just want to thank you all for your attention. I want to thank IDEAM and the organizers of this event for inviting me. And I hope you enjoyed the presentation. And if you have any questions, I will be happy to answer them via a follow-up email. Thank you very much.